let's look at the other algebraic technique that we have for solving linear systems. So let's look at what's called the addition method, sometimes also called the elimination method. All right. This is similar to a substitution method in terms of they're both accurate algebraic methods we can use, more accurate than the graphing method for solving linear systems. But the idea behind the addition method is to add two equations together in the hopes of eliminating one of the variables, and then finish it off by solving the remaining variable. Here's what I mean by that. Let me give you a real simple example to start with. And we had this example when we did the part on graphing here on 6.1, right? Let's look at this here. X plus y is equal to 1. X minus y is equal to 5. All right? Now, if you look at this linear system here, so with the addition method, the way it works is that we simply add these two equations in the vertical format in the hopes of canceling one of the variables. All right? So as you can see, if I simply add these two equations vertically, what's going to cancel out? Well, you see that y is going to cancel out, right? Plus y minus y. Cancel. So what's x plus x? Well, that's 2x. 1 plus 5, 6. So therefore, after I add them vertically, I eliminate y, and I only have x remaining. Obviously, I can solve for x here, so x is equal to what? Dividing both sides by 2. 3. All right? Now, I have x to be 3. How do I get y? Well, I simply plug it back into either one of these equations. So either one is fine, right? Let me choose the first one. So let me choose x plus y equal to 1, all right? And x is what? 3. So let's plug that in. So that's going to be 3 right here, right? So I'll be 3 plus y is equal to 1, and subtracting 3 on both sides. So I still have to solve for y after I plugged in for x, right? So then y is going to be what? Negative 2. Remember, we also got the same answer, but we did it with graphing here. 3 comma negative 2 as our solution here. Okay, so again, the idea is what? To add the two equations in a vertical format to eliminate one of them, and then finish solving for the remaining variable. And then once I get one solved for, I can plug it back in to solve for the other one, as you can see. Right? That's how the addition method works in a nutshell. Right? Of course, it's a little more complicated than that. Let's try another example here. Let me clear out the screen. All right, let's consider this problem right here. Let's look at x plus y is equal to 4, all right, and 2x plus y is equal to 5, all right? Now, notice what happens here. If I simply add these two equations vertically, look what happens. X plus 2x is what? 3x. Y plus y is what? 2y. 4 plus 5 is 9. But it does me no good to simply add them vertically like I did in the previous example, as you can see. Nothing will eliminate, right? The goal of adding them vertically is to eliminate one of the variables, right? Now, let's observe that, well, if only I can get this y up here, or down here, doesn't matter, right? Let me choose the y down here, actually. Right? If I can get this plus y to be what? A minus y, then I'm good, right? Because then I plus y and minus y, then they'll cancel out if I add them vertically. All right, excuse me. So, how do I go about doing that? And how do I go about getting this plus y down here to be a minus y? Well, the way we do that is that we multiply both sides of the second equation in this case, or the first equation. You take your pick. I'll choose the what? I'll choose the second equation here. I want to get this second y down here to be a minus y. So we're going to multiply both sides by what? Well, what's the coefficient of y right here? Well, it's positive 1. How do I get positive 1 to be a negative 1? Well, multiply by negative 1. So so we have to modify this equation in this case, right? To get this plus y to be a minus y, I need to multiply both sides of the equation by what? By negative 1. So let's do that. So let me take the second equation and multiply both sides by negative 1. So negative 1 times the entire left side, 2x plus y, and negative 1 times the entire right side, which is just a 5, right? No big deal there, okay? So let's do that. So negative 1 times 2x is negative 2x, and negative 1 times positive y is negative 1y. And that's equal to negative 5. Negative 1 times 5, negative 5, all right? So after I multiply both sides of the second equation by negative 1, as you can see, I get negative y, which is what I want. All right, so let me recopy the first equation. First one doesn't change. X plus y is equal to 4, stays the same. Now this modified second equation becomes what? Negative 2x minus y, which is what I want, equal to negative 5. All right? Not too bad. Now I simply add them vertically now because the y's will cancel. Plus y minus y. Cancel out. What is x plus negative 2x, or x minus 2x essentially? That's negative 1x equal to 4 minus 5, negative 1. So divide both sides by negative 1 here on the x to get rid of the negative sign. So x will be what? Positive 1 as our solution. All right? Now 1 is our solution for x. But what's the solution for y? Again, I need to plug that back into either one of the two original equations to solve for y. So in this case, let me choose the first one again. All right? So first one, I had x plus y is equal to 4. All right? X is what? X is 1 again, right? So let's plug it in. So 1 plus y. So again, don't plug 1 in for y, right? Plug 1 in for x, because that's what x is. Sometimes we tend to lose concentration and plug in for the wrong number. I see that quite often on exams from students, so be careful, right? So stay focused, right? If x is 1, then I'm choosing the first equation, x plus y is equal to 4. Let me plug 1 in for x. So 1 plus y is equal to 4, subtracting 1 on both sides because I still have to solve for y here. So y is going to be what? 3, 4 minus 1. All right? So therefore, my order pair solution here is 1, 3. Okay? So again, not too bad at all. And for these linear systems, you're guaranteed to have the right answer. You're guaranteed to have the right answer here. So what I mean by guaranteeing to have the right answer on the exam? Well, you can check your answer by plugging in your solution to both equations. Remember, the order pair has to satisfy both equations for it to be the actual solution, right? So if x is 1 and y is 3, what happens? 1 plus 3, well, that's 4. Good enough, all right? Again, x is 1, so 2 times 1 is what? 2 plus 3, 5. So good enough. So therefore, this is the correct solution we're looking for. In this case, to apply the addition method, though, I had to modify the second equation, or the first, you take your pick. I chose the second one in this example here. But we have to modify one of them to get the y's to cancel out. Now, could I have canceled the x's out, you may wonder? Yes, I could have, right? For example, here x is 1 up here, x is 2 down here for the coefficient. If I can get this 1 to be a minus 2, a negative 2, then they'll cancel out. So how would I do that then? I would multiply the first equation of both sides by what? By negative 2 to make that happen, if I chose that route. Again, so you choose which variable you want to cancel, but your final answer should be the same either way. Okay? So let's go ahead and try another example. Let's look at this one here. Now let's look at 3x plus 4y is equal to 10. All right? And 4x plus 3y is equal to 11 this time. All right? Now in this situation, and let's say I want to cancel out the y's again. Again, you can choose to cancel the x's if you like. All right? Doesn't matter. It's entirely up to you. But let's say I choose to cancel the y's again, if you don't mind for this example. All right? So again, we're free to choose which variable we want to cancel. But again, I cannot simply add them because nothing will cancel. I simply add these vertically, right? So that's not going to do me any good. I need to modify, in this case, I need to modify what? Both equations, if you can see that, right? Let's say I want to get the y's to cancel out, for example, okay? How can I make that happen? Well, I have a 4 here on the y. I have a 3 here on the y down here, okay? Now, if I can get both of them to be the same, so what is the same number for 4 and 3? Well, you're probably thinking of the least common multiple of 4 and 3. That's going to be what? 12. So 12 is the common number for these two, for the 4 and 3. So if I can get the top number to be 12, get the bottom number to be 12, and get them to be different signs, they'll cancel out when I add them vertically. All right? So let's do that then. So again, think it out ahead of time, and then what? Decide what to multiply by for each equation in this case. So let me get the first equation. Let me get the 4 up here to be what? To be a negative 12. All right. Let me get the 3 down here to be a positive 12. So then I have negative 12, positive 12, and then they'll cancel out. All right. So let's do that. So I want to get negative 12 from positive 4. How can I do that? Well, I'm going to multiply both sides by what? By negative 3, right? Because positive 4 times negative 3 will give me the negative 12, as you can see that. So for the first equation, I multiply both sides by what? Negative 3. So negative 3 times the entire left side. So make sure you put in parentheses here because we have two terms here. 3x plus 4y equal to, again, you've got to multiply to both sides, otherwise you're changing the equation. So you've got to do it to the left side and the right side. Negative 3 times 10. All right, can we see that? And down here, I want to get a positive 12 from the 3. Well, that's not too hard. Just multiply by 4 then to get positive 12. So multiply both sides of the second equation by positive 4 in this case. So 4 times 4x plus 3y, all right, on the left-hand side, and then 4 times 11 on the right-hand side. Okay, can we see that? Okay, so now let's work it out. So negative 3 times 3x will be what? Let me put it over here. That'll be negative 9x, all right? Negative 3 times 4y will be what? Minus 12y, which is what I want. And that's equal to what? Negative 3 times 10, negative 30. Okay, as you can see, all right? For the second equation, 4 times 4x is what? 16x, all right? And 4 times 3y, that's positive 12y, which is what I want. And that's equal to 4 times 11, simply 44. All right? Not too bad at all. So now I can add it vertically because the y's will cancel out. So if I add these two equations vertically, y's drop off. What is negative 9x plus 16x? That's positive 7x. Equal to what? Equal to negative 30 plus 44. That's positive 14. All right? As you can see. Okay then, so then dividing both sides by 7, we see the solution to be 2. Okay, for x is positive 2. Again, what's y? Well, again, plug it into one of the original equations. I'll choose the first one again. First one was what? 3x plus 4y equal to 10. All right, I found x to be 2 here, so let me plug that in for x again. Okay, so 3 times 2 for x plus 4y is equal to 10. I still have to solve for y here. 3 times 2 is 6 plus 4y equal to 10. Subtract 6 on each side of the equation. So I get 4y is equal to 4, 10 minus 6. So therefore y is equal to what? 1, right? Dividing both sides by 4 without me showing you the algebra there. Okay? So therefore my order pair solution is 2, 1, as you can see. So 2, 1 as our solution. Okay? Again, you can check that by plugging it into each of these two equations. Again, the solution will always have to satisfy what? Both equations. Okay? In order to be the correct answer. In this case, it will when you check it. Okay? So let's go ahead and try another one here. Again, in this case, we have to what? Modify both equations before we can apply the addition method of adding them vertically to eliminate one of the variables, in this case the y. All right? Let's try another one here. All right? Let's look at this equation here. Okay, let's look at 2x minus y is equal to 1. So let's look at this system here. 2x minus y is equal to 1. All right? And 2x minus 5y is equal to negative 1. 2x minus 5y equal to negative 1. Okay? So let's go ahead and apply the addition method to solve this linear system. All right? So how can I do that? Well, again, I can either cancel out the x's or the y's. But try to pick the one that's simplest. And in my opinion here, excuse me, that canceling the x variable is the easiest. All right? So let me choose to cancel the two x's, if you will. And that's not too hard because I just have to get one of them to be negative, as you can see. So let me get the, if you don't mind, let me get the second one to be negative here. Right? To get the second 2x here down here to be negative, I simply multiply by what? By negative 1. So let me multiply. Let me do the work right here. Let me multiply both sides, the left side here, by negative 1, and here by negative 1. So multiply by negative 1 to both sides of the second equation. All right? So first equation stays the same. 2x minus y is equal to 1. All right? And the second equation becomes modified. It becomes what? Negative 2x, which is what I want. And negative 1 times negative 5 is going to be positive 5y. All right? Equal to negative 1 times negative 1. Positive 1. Okay? So now if I simply add these two equations by the addition method, the x's drop off, which is what I want. Okay, when you only want to add vertically when you can cancel one of the variables. All right? Otherwise it makes no sense to add the equations vertically. All right? Here then we get what? Negative y plus 5y is positive 4y, all right, equal to what? 2. So dividing both sides by 4, now as you can see I have the fraction answer here. So y is going to be what? Y is going to be 2 over 4, which reduces to 1/2. All right, 2 into 2 once, into 4 twice, 1/2 of y. Alright? So I have y solved for, but I still have to get x. Okay? So how do I do that? Again, I plug it into one of the two original equations, and I solve for x. Let me choose the first one once again. Okay? So 2x minus y is equal to 1 here. And y is what? 1/2. This time I'm plugging in for y now. So I get 2x minus y, which is 1/2, equal to 1. Alright? Not too bad here. Plugging in the 1/2 of y. How do I solve this? Well, a couple of ways. We can get rid of fractions if you like, but let me just work with the fractions since I can punch in the calculator, but I'll do it by hand here. Add 1/2 to both sides here of this equal sign of the equation. So that takes care of the 1/2, alright? So I'm going to get what? 2x equal to, what's 1 plus 1/2? Well, that's 3/2. That's 1 1/2, isn't it? So that's 3/2. Alright? Now how do I get rid of this 2 here? Divide both sides by 2, but instead of dividing by 2, the same as dividing by 2 is multiplying by the reciprocal of 2, which is 1/2. So multiply both sides of this equation by 1/2. Hopefully you can recall how to solve equations involving fractions. Alright? Not too bad. 2's drop off, so x will be equal to what? 3 times 1 is 3, 2 times 2 is what? 4. Okay, so x is 3/4, y is what? 1/2. So my ordered pair solution will be 3/4, comma, 1/2. So again, you may get fraction answers on the homework. Okay, so make sure we're able to handle that. And just use your calculator to help you. Don't do it all by hand as I'm doing here on the whiteboard. Okay, so it's entirely up to you whether you want to use a calculator or not. Okay, let's try another one here. Let's try this one. Let's look at 2x plus 3y is equal to 7 minus 2x. Alright? And 7x plus 2y is equal to what? 9, let's say. Okay? So, let's look at this layer system here. This one looks a little different here because look at the first equation. There are x terms on both sides of that equation. And so this is not ready to be solved by addition method in this case. Because look, as you can see, if there are x terms on both sides, that means what? That means there are x terms to combine on the same side. So in other words, what I'm trying to say is get this 2x, get this minus 2x to combine with this 2x on the left-hand side. In other words, get it over to the left-hand side is what we're really saying here then. So let me do some algebra before I begin applying the concepts of the addition method. All right? Let me go ahead and get this 2x over to the left side. So 2x plus 3y, all right, equal to 7 minus 2x. Let me add 2x to both sides to make that happen. Okay? Takes care of that. So now I have 4x plus 3y equal to 7. All right, good. So I've combined the x's. It's 4x. All right? You can do it in your head if you want to. It's up to you. But let me recopy the second equation. So 7x plus 2y equal to what? 9. Okay, so again, let's choose to cancel one of the variables, either the x or the y. It doesn't matter, take your pick. Let me choose the y's because, why is that so? Because the common number for 3 and 2 is what? What's the least common multiple? 6. Pretty simple. What's the least common multiple of 4 and 7? Well, that's 28. A little bit more complicated. So let me choose to cancel the y's instead of the x's here. How can I do that? Get the first top, let me get the top one to be what? Negative 6. Let me get the bottom one to be positive 6, if you will. So let's do that. So let me multiply the first equation on both sides. Again, I want this to be negative 6 multiplied by negative what? Negative 2 on both sides. Do it to both sides here. Okay? Here I want this to be positive 6 multiplied by just what? Just 3 on both sides again. Okay? So in this case we have to modify what? Both equations here in order to use the addition method. Alright? So what does this become? Well, negative 2 times 4x is going to continue here. That's going to be negative 8x. All right? And negative 2 times 3y will be what? Negative 6y, which is what I want. And that's equal to what? 7 times negative 2. That's just negative 14. All right? Here, 3 times 7x, that's 21x. All right? And 3 times 2y, 3 times 2y. Let me draw my arrows nicer here. 3 times 2y, that's going to be what? That's a 1 there, sorry about that. 21x, so 3 times 7x, 21x, 3 times 2y, 6y, which is what I want, positive 6y in particular, equal to 9 times 3, 27. All right? Now I can simply add them vertically, the y's drop off, and what is negative x plus 21x? Negative 8x plus 21x is 13x. equal to, well, that's also 13 right here. Okay? So therefore, x is equal to what? 1, right? Divided by 13. Not too bad. All right? Again, what I do next, well, I plug into one of the originals to find the other variable. Okay? Now, you may wonder, can I plug it into the modified? Yes, you can. You can also plug it into the modified and the modified equations here and solve for what? Solve for the remaining variable. That's fine too. I'll choose the original. I'll choose the second one. All right? So 7x plus 2y equal to what? Equal to 9. X is 1, so plug it in. 7 times 1 plus 2y is equal to 9. 7 times 1 is 7, plus 2y is equal to 9. Subtract 7 on both sides of the equation here. All right, not too bad. I get 2y here remaining equal to 9 minus 7 is 2. So dividing by 2 here. Dividing both sides by 2. So therefore, y is equal to what? Equal to 1. All right? So x is 1, y is 1. So the ordered pair solution is just 1, 1. Okay? So not too bad at all, as you can see. But for this problem here, make sure you gather the like terms on the same side here. Namely, get x and y on the left side before you apply the concepts of the addition method. Again, we had to modify both equations to solve this linear system using the addition method. Okay? Let's try a couple more, and then we'll give you some problems to try on Blackboard here. Okay, to post on Blackboard. Right. Let me clear this out. All right, let's look at this example. Let's look at 4x minus 8y is equal to 36. All right, and 3x minus 6y is equal to 27. All right. So a little bit more challenging here with the bigger numbers. All right. Now, which one do you want to get rid of first? Well, let's do the x's then. Let me do the x's if you don't mind. You can do the y's again. You take your pick. But I'll do the x's because the common number is 12 here, as you can see. All right? So let me get the first one to be negative 12. Let me get the second one to be what? To be positive 12. All right? So how do I make that happen? Let me multiply the first equation by what? To make it negative 12 and multiply by negative 3. So let me take negative 3 times 4x minus 8y equal to negative 3. Again, multiply to both sides, right? Times what? 36. All right? How do I get this to be positive 12? Multiply by 4. So multiply by positive 4 to the second equation. 3x minus 6y on the left side, and 4 times 27 on the right side. Again, same number, always multiply to both sides to keep the equation balanced. All right? So make sure we understand that. All right, let's look at the modified equations here. Again, I have to modify both equations again. So negative 3 times 4x is going to be what? Negative 12x. Negative 3 times negative 8y is going to be positive 24y. All right? And that's equal to negative 3 times 36 in the calculator is negative 108. All right? And for the second equation, 4 times 3x is going to be positive 12x, which is what I want. And 4 times negative 6y is going to be negative 24y. And that's equal to 4 times 27, which just happens to be positive 108. Right? If I simply add them vertically now, okay, the x's will drop off, right, as you can see. Negative 12x plus 12x gone. But look, the y's also drop off. Plus 24y minus 24y. They also cancel out. So everything canceled out on the left side. So that's going to give me what? Big fat 0, right? Yeah. That's equal to, well, look, 108, that also cancels out. So that also gives me 0. 0 equal to 0. Well, is that true? Well, sure it is. Of course that's true, right? 0 is equal to itself. Right? Trivial, but it's true. Okay? So what does that mean? That means, again, just like the substitution method, if I apply the addition method and I end up with a true statement, that means this linear system is a what? Is a dependent system. That means what? It has infinite solutions. That means what? The graph of this system is just one line. Okay, so this is a dependent system. Okay, dependent is the answer we're looking for here. Okay, dependent system, infinite solutions it has. Okay, let's try one more here. Let me clear this up. All right, let's look at 2x plus 4y is equal to 3, and 3x plus 6y is equal to 8. All right? So again, let's get rid of the x's again, because the common number is 6. All right? So let me get this to be negative 6. Let me get this to be positive 6. So how do I get 2 to be a negative 6? Multiply both sides by what? Multiply it by negative 3. So let me do negative 3 times 2x plus 4y. Again, negative 3 to both sides, right? Negative 3 times 3 here, this 3 right here, okay? And then how do I get this 3 to be a 6? Multiply by 2. So 2 multiplied to 3x plus, that's a 3 there, sorry about 3x plus 6y. And 2 times 8. Sketchpad can go funny on me at a certain point in the lecture, so bear with me on that. Okay? Try to minimize those interruptions from the Sketchpad as much as possible. Okay then, so let's go and look at the modified equation. Again, I had to modify both equations once again for this example as well. So negative 3 times 2x, negative 6x, negative 3 times, sorry about that, negative 3 times 4y, negative 12y. All right, and 2 times 3x. Oops, sorry about that. Let me finish this off here. Negative 3 times 3 is what? Negative 9. All right, now let's do the second equation here. 2 times 3x, positive 6x here. All right, again, that's a 3 right here. So sorry for the sketch pad giving me some grief here. All right, 2 times 3x, 6x. 2 times 3x is 6x. 2 times 6y is going to be positive 12y equal to 2 times 8, 16. All right. So again, if I simply add these two equations vertically, 6x's drop off, but also again the y's drop off as well. Observe that, right? So I get 0 again, nothing left on the left side, but I do have something left here on the right side. It's what? Positive 7. But again, 0 is not equal to 7, so this is clearly a false statement here. All right? And again, what happens, just like the substitution method, with the addition method, if I end up with a false statement at the end, a nonsense statement like this, then the conclusion is that these two lines are parallel. That means they will not intersect. That means there's no solution, all right, to this system. And that means it's a what? It's an inconsistent system. Okay, so the system is what? Inconsistent. Okay, so again, make sure we know when we have an inconsistent system and when we have a dependent system. Okay.
Okay, before we move on to the 3x3 systems, let's talk more about dependent systems. So earlier we had the example where if I solve by the addition method, you end up with 0 equal to 0, which is always true. So therefore you have a dependent system, which means both lines are the same line, so there are infinite solutions. Now we're going to express the solutions to dependent systems as an ordered pair, but the ordered pair is going to be in terms of x. Here's what I mean. Let's do another example here. Let's take a look at something like 2x plus 3y equal to 6, and 4x plus 6y is equal to 12. Right? So recall that earlier we're going to times the first equation by negative 2 to get rid of x. So let's times the first equation by negative 2 to get rid of x, both sides. All right. So we're going to get, let me just write these result below. So we get negative 4x, all right, and minus 6y equal to 6 times negative 2 is certainly negative 12. So now we can add this equation and the modified first equation together. So x's drop off and y's drop off. So we get 0 on the left as well as 0 on the right because the 12's also canceled out. Again, this means that both lines are the same line. So therefore we have infinite solutions because this equation is always true. So always true. So we have a dependent system. But we're going to express this dependent system as an ordered pair in terms of x. All right. So, and how do we do that? Well, to do that, then we need to get one of these equations in mx plus b form. In other words, pick the first equation, for example. Let's pick the 2x plus 3y equal to 6. Let me go and get it in mx plus b. Solve for y. So subtract 2x on both sides, as you recall. Sorry about that. Takes care of that. So we're going to get 3y equal to negative 2x plus 6. Divide by 3 on both sides. So then we're going to get y equal to negative 2/3 x plus 2. So negative 2/3 x plus 2 is the mx plus b form of the first line, right? Again, both lines is really the same line. So therefore, my dependent system expressed in the ordered pair solution will be then x for the first variable for the x coordinate and y for the second for the y coordinate, but y is going to be right here, negative 2/3 x plus 3. So we'll write negative 2/3 x comma y, so x negative 2/3 x plus 2. So this will be the order pair solution for a dependent system. Right, so for dependent systems on the homework, make sure we express it in terms of x. X for the first coordinate, y for the second coordinate, but y is going to be solved for in terms of x, which we've done in the past. All right, so not too bad, just make sure we do that for dependent systems here. Now let's move on to the 3x3 systems. All right, now let's take a look at the 3x3 systems and use the addition method to solve these here. So 3x3 systems are basically 3 equations and 3 variables. So instead of having x and y, we now have x, y, and z. So let's take a look at the concepts behind solving these types of systems. So let's look at the first example that we have for you. Let's take a look at something like x minus y plus z is equal to 6. First equation, all right. Second equation, 2x plus 3y minus z is equal to 1. So it's 1 there, sorry about that. And the third equation is going to be x plus 2y, 2 right there, sorry about that, plus 2z is equal to 5. All right? So let's take a look at these 3 equations. So first equation, second equation, third equation. Now the idea behind solving these 3x3 systems is to pick any of these 2 equations to combine and eliminate one of the variables. So for example, we could pick the first equation and the second equation and to eliminate what? Z. Looks like easiest to get rid of z right here. All right? So let's go and combine equations 1 and 2. 1 and 2. So I'm writing the equations in parentheses, equations 1 and 2, to eliminate z. So I'm getting rid of the z variable in these first 2 equations. So let me go, simply just add these two to do that, obviously, right? So let's do that. So x minus y plus z is equal to 6, and 2x plus 3y, that's a 3 there, minus z is equal to 1. I'm simply going to add them together. So z's drop off by the addition method. We get 3x plus 2y is equal to 7. So I've gotten rid of z, and I'm down to an equation of 2 variables. So the key is to what? Is to eliminate one of the variables to get it down to from a 3x3 system to a 2x2 system. Right? So we're reducing the 3x3 to a 2x2. How do we do that? Well, let's pick a different combination of equations. I could pick 1 and 3 if I wanted to, or 2 and 3. I'm going to choose 2 and 3 here. So let's combine equations 2 and 3. So combine equations 2 and 3. All right, so second equation, third equation. And again, the key is what? It's to eliminate the same variable z. So we have to eliminate the same variable for the second combination as well. That way, we're reducing the 3x3 systems to a 2x2 system. All right, so let's do that. So let's go and recopy 2 equations there. So equation 2 was 2x plus 3y minus z equal to 1. Third equation was what? X plus 2y plus 2z equal to 5. That's z right there. Sorry about that. All right. So in this case, since I need to get rid of z, I need to times this first equation by 2 to make this a negative 2. So I'm going to times by 2 to both sides here. So times by 2 to the left-hand side, 2 to the right-hand side. All right. So let me write this new equation below. So we're going to get first equation becomes what? 4x plus 6y, distributing the 2 there, right? Minus 2z equal to 1 times 2 is 2. Again, the second equation stays the same. Let me just recopy below. X plus 2y plus 2z equal to 5. Now I can simply add these to get rid of the z variable. Oops, sorry about that. That's a 5 right there. All right, so now I have 5x, all right, plus 8y is equal to 7. That's an 8 right there. Sorry about that. All right, so now I have these 2 equations here. 3x plus 2y is 7. 5x plus 8y is 7. So I've narrowed my 3x3 system to a 2x2 system. Let me write this equation below right here and solve this 2x2 for x and y. So we have 5x plus 8y equal to 7. Right? Now, to solve this, I'm just going to get rid of the y variable because I just need to get this to be a negative 8. So I'm going to times both sides by negative 4 to make that happen. So negative 4 on both sides, the equation. So let me just write it below here if you don't mind. So we're going to get negative 12x plus 8y, I'm sorry, minus 8y actually, sorry about that, because that gets rid of y obviously, right? Equal to negative 28. All right, negative 28. Okay, sorry for the sloppy writing here. It's kind of tough to work with a sketch pad. All right, so doing the best we can. All right, so we're going to get negative 7x. If I combine these, 8y's go away, equal to negative 21. And obviously, if I divide both sides by negative 7, then x will be what? Positive 3. So we see that? So we have x solved for. Now let's get y, because we have this 2 by 2 system here to get y with, right? So we're solving for x first in this case. Now we're plugging back in to get y. I'll use the first equation here. 3x plus 2y is equal to 7 was the original, right? So let me do that. So 3x plus 2y equal to 7 was the original equation here on after I modified it, right? So we're gonna of the 2 by 2 that is, right? So x is 3. Let's plug it in. So 3 times 3, which is 9, of course, right? Plus 2y. 2 right there, sorry about that, equal to 7. So we'll get 9 plus 2y is equal to 7. If I subtract 9 on both sides, takes care of that. So we're going to get, let me continue here since I ran out of space, we get 2y is equal to negative 2. All right? 2y is negative 2, so therefore y is equal to negative 1. If I divide both sides by 2, that's a 1 right there. Sorry about that. All right? So then we have x is 3, y is negative 1. So how do I get z to finish it off? Well, to get z, if I have x and y, just go back to the original 3 by 3 system and plug in x and y to get the z. So it looks like it's easiest to use the first equation here, so I'm going to use that. All right? So let me copy it down here since I ran out of space here. So if you don't mind, let me go down here. So I'm going to copy the first equation, x minus y plus z is equal to 6. That was the original first equation, right? So we know x is what? 3. Y is negative 1. Let's plug those numbers in. So 3 minus negative 1 for y plus z right there, sorry about that, equal to 6. So then 3 plus 1, or 4, that's a 4 right there, plus z is equal to 6. If I subtract 4 on both sides, sorry, running out of space here, but let me just do the subtraction of 4 here, just so you can see that. That gets rid of that. So z is equal to 2. 6 minus 4, right? Can we see that? So we have x and y and z solved for. So my order of pair solution is going to be what? 3, x comma y comma z, right? So go in the alphabetical order. So 3, negative 1, 2. So my solution input up here is going to be 3 for x, negative 1 for y, and 2 for z. So that's the solution up here, right? So 3, negative 1, 2 is my solution here, right, for the 3 by 3 system that we have. So again, the key idea is going to be what? It's going to be to pick 2 equations. So we chose the first 2, right? 1 and 2. We got rid of z because it was easy to do that, right? We're left with x and y equation, right? Now I pick a different combination. In this case, I'm picking equation 2 and equation 3 here, 2 and 3 combining. And again, the key is what? To eliminate the same variable z. So you have to eliminate the same variable. That way you get down to x and y again. Now we have a 2 by 2 system of x and y. We can solve it with the addition method, or even the substitution method if you want to use that. But addition, we'll just stick with the addition method. All right? And once we get x and y solved for in the 2 by 2 that we have left over, we plug it back into the original 3 by 3 system to get the z. We got z to be what? 2 in this case. So my three numbers that I need here for x, y, and z will be 3, negative 1, and 2. All right? Let's try another one to give you a better feel for this concept here. Let me go clear out the screen here. Let's take a look at one more 3 by 3 system. Let's look at this 3 by 3 system here. So x plus y plus z equal to 0. My first equation. Second equation, x plus 2y plus 3z equal to 5. And third equation is going to be 2x plus y plus 2z equal to 3. All right. So let's take a look at these three equations here. Again, the key idea is what? Reduce it to a 2 by 2 by picking any two combinations to combine and getting rid of one of the variables. And then pick a different combination to combine and get rid of the same variable to get that 2 by 2 system that we need to finish solving the rest of it. All right. So let's combine equations 1 and 2 again, but this time looks like I'm going to get rid of x here, if you don't mind. So it looks like for me it's easiest to get rid of x here. So I'm going to combine 1 and 2 and eliminate x. So combine equation 1 and equation 2 to eliminate x. To eliminate x. All right. So let's do that. So let's copy the equations again. So x plus y plus z is equal to 0. And first equation, second equation, x plus 2y plus 3z is equal to 5. All right. So let's go ahead and times the first equation by what? -1 to get rid of x, for example. All right. So we're going to get, let me write the result below. So we get -x minus y, distributing -1 there, all right, can we see that? And minus z to equal 0 times -1 is still going to be 0. So that gets rid of the x by adding them together. 2y minus y is going to be 1y plus 2z equal to 5. All right? Now, let's look at the second combination. This time, I'm going to combine equations 2 and 3. Again, the key is what? To eliminate the same variable, variable x. So you have to eliminate the same variable to narrow it down to a 2 by 2 system of y and z. So let's combine 2 and 3 now. So let me do it. Let me go and combine equations. Okay, let's combine 2 and 3. So equation 2 and 3. Again, the key is to eliminate the same variable. So we're going to eliminate what? X still. All right? So let's do it. And let's copy these equations here. So x plus 2y plus 3z equal to 5. Second equation, right? Third equation, 2x plus y plus 2z equal to 3. All right? So let's go ahead and times it by what to get rid of x. Again, it's the case to get rid of x, right? In this case, because we got rid of x in the first combination, do the same thing, the second combination to get rid of x. So I'm going to times it by what? -1 in this case. -2, excuse me, this time, because I want to get -2x right here. So -2 to both sides. Sorry about that. So let's distribute the -2. Distributing now, we get -2x minus 4y. All right, and -2 and 3y is going to be what? -6z. Equal to 5 times -2 is going to be -10. All right, so if I add them together now, as you can see, the x's go away. What do we get on y? -3y, if you will, minus 4z equal to -7. All right, so we got down to what? A 2 by 2 system now, right? Of y and z. So let me write this under this equation here to help you see that. So -3y minus 4z is equal to -7. Now let's solve this system for y and z first, and then plug it back to the original to get x, and to finish off the problem. All right? So let's do that. So take your pick in terms of that. So I'm going to get rid of y here again, if you don't mind. So I'm going to times it by what? By 3 on both sides to get rid of y. So we're going to get 3y plus 6z. So you can see 3 and 2z is 6z equal to 15, 5 and 3. So if I add them together now, my y's drop off. I get what? 2z is equal to what? Positive 8, right? -7 plus 15. So z is clearly going to be what? Positive 4 if I divide both sides by 2. Right? So we got 4 for z. Then let's plug it back in, the 2 by 2 again, to get y. So I'll use the first equation. This was y plus 2z equal to 5. So y plus 2z equal to 5 right here on this top equation before I modified it. So z is 4, let's plug it in. So y plus 2 times 4 is equal to 5. So y plus 8 is equal to 5. If I subtract 8 on both sides, then you can see that y will be what? Negative 3, as you can see, right? So y is going to be negative 3. Then I have z to be 4, y to be negative 3. Plug these numbers back into the original 3 by 3 system to get x. So let's plug it into the first equation. That looks the easiest there, right? So let's plug in negative 3 for the y and 4 for the z to get, and then solve for x. So we're going to, let me do it right here. So we're going to get what? X plus y plus z equal to 0 was the first equation right up here. So my x is going to be my last variable to solve for in this case then. So x plus y, so x plus negative 3, all right, plus z, so plus 4 is equal to 0. So negative 3 plus 4 is what? Positive 1. So x plus 1 is equal to 0. So obviously x will be what? Negative 1 if I subtract 1 on both sides here. That's a negative 1 there. Sorry about that. All right. So then we have x and y and z solved for. So my order pair solution then, I write it up here, will be negative 1 for x. Y is going to be what? Negative 3. And z will be positive 4. All right. So we have the following solution here of negative 1, negative 3, positive 4 for x, y, and z respectively. All right, so again, the main theme to take away from the 3 by 3 system is that we're going to reduce it to a 2 by 2 system by what? Combining two equations together, such as 1 and 2, to get rid of the x, right? And then combine a different set of two equations, 2 and 3, for example, to get rid of the same variable x. Very key here, right? You got to get rid of the same variable so you get that 2 by 2 you need. Right, and then we finish solving the 2 by 2 to get y and z, and then we plug it back in, plug these numbers back into the original 3 by 3 to get x. All right, so that's the gist of the 3 by 3 systems in terms of solving them by the addition method. Now let me go and clear out the screen and give you the problems that I want you to solve and post into Blackboard here. So let me go and clear this out. All right, let me go and paste this on here. Okay, so let's go ahead and solve these three problems here on, and post your solutions to Blackboard. Right, so solve these three systems by the addition method and post solutions into Blackboard. Okay, take care and have a great day.